Hello. We're on, right?
I don't know. Good question. Okay, looks like we're up.
Nice. Okay. Yeah, so sorry about the little interruption in the beginning. I'm going to be going through the Onyx, the new Onyx template, and more importantly, the revised task bundles. I'm going to see if I can switch to my screen. Here we go. Okay, so I'm assuming that most people have used the previous Onyx template, or at least seen what Onyx job descriptions kind of look like. So like what catalog functions or catalog maps or lifecycle maps look like. And the biggest thing we're bringing forward with this is like a logical way to group up what your task contains. So instead, when you previously would have just been specifying functions and giving them elements to work with through lifecycle methods, what you can do now is package them up into these things, what we call task bundles. And task bundles really are comprised of two different sections. So we have the actual definition, which you'll recognize, like where you'd specify, for example, here we're specifying a catalog entry that uses the function myfn, right? Thus, we have some lifecycle things to inject down here. And then the second piece we have is we have schema validation built into the task bundle itself. So this will kind of co-locate everything having to do with a logical like unit of work. So you'd have a task bundle for, say, writing to SQL, or a task bundle for doing word count, right? So I'll show you an example for how we can actually use these now. So if we have a base job, right? A base job is a regular Onyx job description that has a workflow, catalog, life cycles, etc. And you can see all these entries are empty, right? If we go back up to the top here, we see what our task bundle looks like. We can use this function in Onyx, the Onyx job namespace called add task. And add task will intelligently merge your task bundle with any job that's being passed to it. So you can see we're using the threading macro to pass the base job through to add task. And add task will both verify that all the schema checks pass for your task bundle that you specified. So for example, here we're saying that it's required that special key is a number. You can see it is, and that for our life cycles, connection string is a string. So add task will instrument the base job with your task bundle, and it'll give you some validation errors. If, for example, if instead of a number, we accidentally had a string. You can see we'll get, oops, this is in the way, sorry.
Hey, Gardner, can you make your text a bit larger? We're getting some responses
for yeah.
Larger font size. Thanks. I think I see it there. It's under change font.
Where is it? Ah, perfect. Thank you.
There you go. You're welcome.
How's that look?
Awesome, good. Chat me up in Clojurians if you need anything, guys. I'll forward it on. Thanks. Good.
Okay, so the task bundles, they task bundles, as I was saying, they group together schema checks with the actual tasks themselves. We'll just change that back so everything evaluates. But yeah, so they allow you to instrument your Onyx job maps in a composable way, right? So come down here and we want to have something a little more flexible than just a statically defined map. What we actually do is we have a function. Say we want to make a task that just increments a number in a side of a segment that's located at a key path, right? And what we do is we basically take the task map we had, like the same shape we had before, where it specifies a task and schema for that, and we can add in. We have we can add in how we're going to spec things out for parameters, or and end up doing schema checks on that too, right? So what we realized was that at some point that it doesn't really play that well with your like citer editors that are doing autocomplete or something like that, because for the arities we were having, we were just specifying the like task name to instrument to attach it to a task, and options to merge in with that. So like that would be any kind of parameterization you were doing. We realized that really what you often want to do is be able to see at your editor while you're writing out your Onyx jobs, like autocomplete or the IntelliSense, whatever you want to call it. So we have a second arity on a lot of these task bundles that shows just that. So if we wanted to do ink key, for example, I'm not sure if this will actually show up with the font size. Yep, it does. We show, oops. Yeah, we show two arities to kind of give you a like a bit of a
Garner,
helping
do you want to jack up your font even a little bit more? Getting some more responses.
More? Okay.
Yeah. Can you still see it on your screen? I know it looks a little bit different once you start broadcasting.
Yeah. Sure. I can. Let me get rid of this guy.
That looks great now for me. Yeah.
Okay. Cool. So yeah, we often want to have two arities to build up our task bundles, and ultimately what this does is it just returns the same. I mean, it's the same thing. It's just going to return a regular closure map that's in the same shape as the original example, but by using the two arities, we're able to do kind of like an IntelliSense kind of thing. And I'll do it again for if anyone missed it with the small font, but it allows you to specify things while you get the nice little helper window. Or at least I enjoy that. So an example of what this would look like with add task, you can pass add task in a function you're calling, and it makes it a little bit easier for you to read. You read it as passing the base job and adding a task to it, and the task is increment key at our path, which is right here. And that'll still apply all the same schema checks and everything. Sorry, I'm having a little trouble jumping around with the font size, but bear with me. The last thing we have is these things we call bundle modifiers. And what they allow you to do is, there's often times where you want to add things to task bundles after they've already been defined. So for example, this is an example of how to add logging to a task bundle. And essentially what it does is you're going to reach into the task bundle before it gets merged and add in your own, for in this example, it would be life cycles, right? But you have total freedom to do whatever you want with these. You can have them modify the catalog entries or add more flow conditions, whatever you'd like. And the way you use them is just passing them as the extra arity to add task. So you can have multiple of these, right? They can do different things, but they all still compose together. You can even inject your own, like more stringent schema checks if you wanted to with these. It just lets you have one last grab at the final resulting task bundle map before it gets merged into the Onyx job. So as you can see, this actually comes up, and before our task bundle didn't have any life cycles, but now you can see it added in the log batches lifecycle. So you can, down here I have an example of how you'd actually use these for composition, right? In this example, we have two different task bundles. One is for incrementing keys, right? That's the one we built up. And this is actually one we provide now in Onyx Core as a core async task bundle. And what this will do is it'll create a core async channel that you can access later through a convenience function we provide. But it creates a core async channel, the related life cycles, and the catalog entry to have it be the in of your workflow, right? And you can see we use both of the task bundle modifiers. We use the same exact one and just instrument both separate task bundles with the modifiers, and it provides the same functionality. So you would end up with logging on both of these. And if you didn't want it on your input, you could remove it and resubmit the job. Let's see if I can switch out of here. Okay, so basically that's a quick run through of what task bundles look like. They're just nice units of composition that we found they fit a lot of use cases we run into. So that's the biggest change with the new template, and I'll actually switch to that. So right now, all I did was run line new Onyx app and called it Onyx app. And I passed it the Docker arguments, which there's some documentation around that, but basically it gets it ready to for running in a Docker environment, right? You're given a brand new app, and all it has is it has a job definition, right? Which is using these task bundles that we outlined before. And all this job definition is doing is it's just taking input from core async input, running it through inc key, the same exact task bundle we made up before, and running it to an output. And we can actually go and test this right now. Well, I'll just show you the test first. We have a regular Clojure def test that uses our test environment macro to send this collection of segments through, and we just verify on the other side that everything was incremented correctly. And that's kind of another powerful feature of doing things with task bundles, is that you can set up your jobs in a namespace that's agnostic to what environment it's going to run. And then say, for example, in your test environment, if you don't want to have to spin up Kafka or MySQL to run tests, then you would just instrument it with your own task bundles for, say, core async or Onyx Seek. The other thing with the job that you'll see that's different now is we have this multi-method that you can define called register job. And you basically give it a title. So we give this as a title basic job, and all it does is it's going to register the calling, like the ability to call this job to a multi-method that's defined in Onyx Core. And you'll see why this is important in the next namespace. So this is also included with the template. We have, and it's kind of a little more difficult to see with the font, but you'll see it's a little command line utility that we built to wrap up all of the trickiness around like job submittal or job submission and starting up peers. Basically, instead of having multiple entry points now, your jar is going to have one that you can dispatch on, either if you're starting peers or you're submitting a job. Submit job actually calls that multi-method from the previous namespace with a job name you pass it, right? So if you can imagine if you had multiple different jobs, and that's how the folder tree is set up. So you have jobs, and you could have basic word count, different jobs like that. You could imagine registering them all, and then to start one, it's just calling your compiled jar or Docker container with a new entry point and that entry point being your job name. And that'll go through the same config that the rest of your cluster was started up with. So it makes for a lot easier job submission if you're using a tool like Docker Compose or Kubernetes. So that's the template, and the template as it stands now, right? This is like if you just did Onyx new app, right? But we also have this a little larger of an example that we've been working on. And let me kill these buffers. We've been working on one example that's we've been calling it Twit, right? And it's actually on GitHub right now as, I believe it's, we just put it up, Onyx Twitter sample. It's up on GitHub. You can grab it whenever you'd like. And it's a live streaming, like it counts hashtags and discovers what's trending based on the live Twitter feed. So I'll just jump over and actually show you the job. We have a job called trending, right? And we have our core job, we're going to call it, right, is trending hashtags. And we found it really beneficial to separate things out into their core components away from the leaves or roots where you'd have dependencies on external services. So we can distill down our problem to, we need to grab the regular plain old closure map that's being fed to us. That's hopefully in the shape of a tweet. And we're going to reshape it into this format, right? And I'll go over that task bundle in a little bit. It basically is doing get ins and then associating the keys at the new paths. So for text, it's going to get in at text, ID, get in at ID. It's a little redundant, but it was just an example. So. So we're going to reshape the segment into the expected shape. We're going to split all the different things that are text, right? So we are assuming that you have tweets that are like, "Hello world," right? And we're going to split all the different hashtags and tie them back to the same tweet ID, and then we're going to window those grouped on the different hashtags, right? So if you're familiar with windowing, basically we're gonna have a windowing count on each bucket of tweets. So if we have 2 tweets for Onyx, a tweet for MTV or something like that, that's just the most recent one I've seen. But those will all get bucketed together into a constantly incrementing count for our window. And this is before any kind of external dependency is introduced, right? We're not saving this anywhere. This is all still within Onyx. That's kind of the goal of separating these things out. And if we jump over to our test namespace for our trending hashtag, you can see we have some stuff up here to just generate a bunch of hello hashtag world tweets. And what we actually do is now we use task bundles here to build up a test job, where our test job uses core async inputs and outputs. And instead of triggering to something like durable storage, like MySQL or something, we actually just trigger to an atom. So immediately you can kind of see how by breaking things up like that and using task bundles together, you get a lot more power over like your core business logic in your job. You can keep it very decoupled from the underlying infrastructure. And essentially, we have a couple of convenience functions that just know how to grab the core async channels or atoms that were created, and we can run tests over that. And all we're doing here is we're just testing that we actually have a count of 10 for the hello world, because we know we generate, or sorry, the world hashtag, because we know we generated 10 of them. Now, if we go back to the job, right, the trending job, you can see that we register it as the trending hashtags job. And in this example, we actually go through and see we grab the original, which was the base job, and then all we do is thread it through the rest of the task bundles. It's the exact same procedure we did with the unit, the test in the test namespace, but in this time we add the actual Twitter stream, right, which is an Onyx plugin that we have now, and then we add in a core async output. And usually you probably wouldn't do that, but because we don't actually care about the output, we only care about the results of the windowing. It's fine to just dump everything to a core async channel and throw things away. But for our task bundle modifiers here, you can see we actually trigger to SQL now. So we're going to be writing our window state to a SQL table, and we have a task bundle modifier that will actually fire Joplin migrations. So so we can always have up-to-date table schema. And I'll give you just a quick peek at that. We have that in we have our this is what our table essentially looks like. We're just going to have our hashtag string, the how many we've seen, and what the window time span we've seen it in. So we have that registered, our trending hashtags job, right? And there's a little bit more around how configuration gets passed around. I'm not sure how many people have used Arrow before, but we've definitely become pretty heavy users of it. It's a kind of a language over configuration. I'll show you what it looks like quick. But essentially just a closure map, right? But we use the reader tags to be able to dispatch on different things. So when the actual config.eden file is read in, we'll look at things like profile. We'll actually switch based on args passed to the reader function. Just like if you were to pass it Docker, the Docker keyword as a profile, then it would know to read only the Docker versions of a map. And we also have the other tags like hash env, which will read an environment variable. So you can, that's basically what we're passing in here for our job registrations, right? So, just one second. So we have a job registered that is going to just essentially count our hashtags and persist them to SQL. And I'll dive a little bit into what the actual tasks look like. So we have this, the original one, if you remember, was that reshape segment task, which was given, you basically give it, say we had a map that was name gardener, age 22, and location Rhode Island. So all this is doing is going through, and this is actually a pretty common function that you'll end up using, and looking for like paths. So if I wanted to reshape this segment into just having name, I could just have it do gardener. Or if it was a nested map, like first, like that, it would be something like name first, right? And name would become gardener. It's just doing a get in. But you can see how we define the function and the bundle that wraps it in the same namespace, right? That's a common pattern we have. It keeps things local to each other. In this, you can see I didn't use the two-arity form because I felt it's just a very simple task to wrap, and I just used the one-arity form because you're pretty much always just going to want to specify it like that. And there's I didn't have a schema definition for this either, because just for the same exact reason, there's not really too much to mess up, you know. But if we dive into some of the other task bundles we have around actually manipulating tweets, you can see they get pretty in depth, right? You have like up here for emit our hashtag IDs. You can see we use the same pattern with checking our schema types for that they're sequences of any keys. That's because you can use either keywords, symbols, or numbers for doing get-ins, and that's essentially what this is doing. But then what I think is a really interesting piece is here with our task bundle modifiers that will be injecting connection URI information into our persistence, like the pieces that are triggering out to SQL. So you can see basically it takes the same shape as everything else that's a task bundle modifier, and by doing that they end up being quite composable. Maybe I think I'm gonna switch to, I can show you an example of how you now that you have this and you can actually test these, right? You can test them with line tests, right? So once you have it actually up and running, you can go to into our namespace, and we have just the top level namespace. And what you'll do is Docker compose up, or sorry. Well, we'll end up building the Uber jar, and then the Docker image is included with it. And while that's building, I can just give you a quick little peek at that. The important thing with the Docker image is that for when you're running Onyx, you really need two pieces. You need the peer namespace, and then you need the media driver, which is a portion of what we use. It's a service that our messaging library uses that has to run out of process. And it'll if you've used Docker before, you know that you can't spawn two services. So we use an init service that'll actually manage both of those services running for us. And this will get you up and running with a working Onyx peer, which will also have your media driver running at the same time. If we go check out our Docker compose. So I actually have my Twitter keys here right now because I have to show you guys somewhere, but they're in read-only mode, so hopefully you can't do too much damage with them. But our Docker compose image specifies 3 different services we want running. We want the peer, which is our regular Onyx peer, and we're going to specify Onyx ID, which is an Onyx like tenancy ID. Or an Onyx cluster ID. It's a way to have multiple different versions of clusters running against the same Zookeeper service. And then we just specify that we want 8 concurrent peers running. And those environment variables are set through, or actually can be picked up through, we go look for Onyx ID, you can see we have these examples of where the hashtag env picked up Onyx ID from the environment. And this is going through Arrow. So this is how we're passing things to our running application, is by setting them through the environment, but then picking them up in our configuration script or our configuration file. And it's the same thing with our Twitter keys, right? So here we were setting, that's one of the sticky points. You have to actually set the shim size of dev shim, which is like a memory, it's like a memory mapped file or folder for the Aeron peer or Aeron media driver to actually use. That's just an infrastructure worry. And the rest of the services we have should be pretty familiar, just Zookeeper and MySQL, where we're creating a database called Onyx. And it looks like this finished. Okay, our Docker container successfully built. And you can see we tagged it with the tag peer image, which was the image used right here, or right here. And we should just be able to do Docker compose up. That'll take a little bit to run. You can, it gets quite chatty with Zookeeper, but you can see we have our media driver starting up as part of the same container as our peer. Sweet. Okay. Looks like our peer started up successfully and was able to connect to Zookeeper. So it's now in a waiting state, and it's waiting for a job, right? So to do job submission, if you remember from our core namespace, we had these two different like pathways you can go through with the compiled jar calling the core namespace. You can either start peers, which we already did, or you can submit a job. And the submit job is actually going through going through what you registered on the register job multi-method. So Docker Compose gives you this one-off command called Docker Compose run, and I don't think this is going to fit on my screen. See if that works. Okay, awesome. So Docker Compose run will take a actual. It'll take one of these services, they call them. So it'll just run a new version with like like a one-off container of that service. So we're going to say take the peer service, and we're going to switch our entry point from that init script to Java, and run our peer jar with under the twit core namespace. And actually, I can just drop this for now. We can do minus help, right? And this will show you the help menu that now all templates come with. It does take a little bit. You have to wait for closure and the JVM to load up, but it'll give you some options and tell you you can either start some peers or submit a job. And right now, all our peers are in just a waiting state, so we do want to submit a job. To do that, we're going to call submit job, and then if you remember from previous where we actually had our job here under the in the jobs trending namespace, we registered it as trending hashtags. So that should be available now under there we go, under submit job, and I have a misspelling here. And all we're doing here now is calling the P option, which specifies a profile to pass to the config. And you can see in our config, we're using profile to dispatch between environment types. So, so we know when we're using Docker, we want to actually pick up the Onyx ID from the environment. And when we're running locally, we want to pick up the tenancy ID. We want to pick up the tenancy ID from the environment when we're running in Docker, but when we're running locally, we want to just use one. And you can see other places we're using that. So like, do we want to use the embedded media driver locally? Yes, but with Docker, we actually run it, right? So I'm just passing, for a profile option to use, we want to use Docker. What this will do is it'll run a one-off container for us. Oh, cool. Okay, so that's another thing. It looks like I misspelled this job. I called it trending hashtags, but you can see that it came back and said the only available jobs we have to run are trending hashtags. So let's try that again. Font size is messing with me a bit. Sorry. So this is actually going through and looking at what's defined on the multi-method and coming back for options. So you could imagine if you have a larger Onyx project that there would be a lot of, it'd be kind of nice to have spell check basically for your job names. So you can see we actually successfully submitted this job ID. And if we jump back to our cluster, it looks like our peers are booted up and enough peers are active and they are starting tasks. So at this point, we should have tweets flowing through the system and being dumped to a MySQL database. And if we jump back up here, I'm hoping, yeah, you can see these messages here that we actually went through a database migration too. If you remember from the original job in the task bundle modifier doing Joplin migrations, all you do is you give it a config, you pass it some config, that's the path to a Joplin migration folder, and it'll start running your migrations if they haven't already ran on the database. We can actually check out that database going here. If you remember, we created the Onyx database, and we can just select, we have a table that we're writing to, that's the trending table. And you can see now we have hashtags that are coming in being ranked and by how they're trending. And they're all multiples of 5 because in our actual Twitter trigger function, trigger to SQL, you can see we're firing every time a window fills up with at least 5 elements. So when a hashtag has been trending and it's been mentioned at least 5 times, then that's when it's fired. So you can see this is live updating, or sorry, it's constantly being updated, but I'm just rerunning this query. That's essentially the Onyx Twit project, and we just released this. I'm sure we'll figure out how to put a link into Google Hangouts or something to get at it. But the idea me and Mike were kicking around last night was to have it kind of be a showcase for some Onyx type stuff. So being able to show off stuff like windowing or flow conditions through that venue ends up being pretty nice because no one has to worry about setting up a database and seeding it with data because there's always Twitter data coming through. That's kind of the plan with the Twit project, or the Onyx Twitter example project, I should be calling it now. But this is kind of, we decided to separate things out differently than we did last time with the last template. The last template we had like a kind of a admittedly unreliable setup with like curling from meetup.com into Kafka, and it became a good amount of overhead. And we're hoping that by separating it out into our simple template, which was just this Onyx app that has a couple little things, all it has is a basic job that pulls from core async, right? And having that as your starting point to a bigger, more robust example that we can maybe showcase some more stuff through. We're hoping that that'll make things a little less confusing. The starter template also has Docker capabilities, right? So just delete these. This comes with, if you specify the plus Docker option, it comes with a Docker file and a Docker Compose setup, but all that does is start a Zookeeper service for your peers to connect to. All the other infrastructure concerns are up to you and allows you to customize and kind of move a little bit quicker without having to delete a whole bunch of boilerplate. So that's essentially the new template. I definitely, if anyone has any questions, I think we have a little question app built into the Hangout that you can ask them through. I'd love to answer anything anyone has.
I couldn't figure out how to make the Q&A app work. So if you have any questions about Closurians or Gitter, we're on pretty much every chat room.
Yeah, I'm happy to stick around for a while and talk about this stuff. Definitely went, I'm not too sure if I went too fast or too slow. I've had my head in this for a long time, so.
Cool. We'll field questions on the chat room. Let us know if you have anything. Thanks for tuning in, everybody.
Yep, thank you.